The substituents are any other groups, not functional groups, that stick out of the main chain. These are most commonly halogens, members of group 7, or side chains. We list these substituents onto the front of our compound's root word. Let's start with the halogens. In organic chemistry, we use the letter X to represent any one of the halogens in group 7. X is therefore Cl, Br, I, or F. The words we use to tag these substituents onto the front of the root word are Cl, chloro, Br, bromo, I, iodo, or F, fluoro. The positions of the tags are identified in the same way as the positions of the functional groups. In the following example, the chloro group is closer to the left side of the compound. So, if we have to number from the left, it would land on carbon 2, making it a 2-chloro group. The name of this compound is 2-chlorobutane. If we look at this compound, we see that we have a hydroxyl functional group and a chloro group that both need positions allocated. In this case, the functional group with oxygen always takes preference over the substituents. The hydroxyl group is closer to the right-hand side of the molecule, and so we start numbering from the right. We see that the hydroxyl is allocated position 2, and the chloro group is allocated position 5. The name of the compound is 5-chloropentane-2-ol, or 5-chloro-2-pentanol. The other type of substituent that our organic compounds can have are side chains. These are carbon chain branches that do not form part of the main carbon chain. We call these side chains alkyl groups. To name the side chains, we first need to count how many carbons make up the side chain. To this, we assign the same carbon-counting words we used for the main chain. So, if our side chain is 1 carbon long, the name of the side chain will start with meth. For 2 carbons, we use eth, 3 carbons prop, and so on. The suffix for the side chain is always -il. So, a side chain containing 1 carbon is a methyl group, containing 2 carbons is an ethyl group, and containing 3 carbons is a propyl group. These substituents are tagged with positions in the same way as the halogens. The following compound has a main chain of 5 carbons long and a side chain of 1 carbon long. Now, if you're wondering how to tell the difference between the main chain and the side chain, the main chain is simply the longest number of carbons in a row. Remember that your main chain must contain the functional group and give you the simplest side chains. In our example, we choose our main chain to include the carbon carrying the functional group. We number our chain from the side where the functional group is closest to the end. This places our side chain on carbon number 4. The name of our side chain is therefore 4-methyl, 4 indicating the position and meth indicating the number of carbons in the side chain. If we put it all together, we get 4-methylpentane-2-ol or 4-methyl-2-pentanol. So, what happens when we have more than one substituent on a carbon chain? Keep the following in mind. When numbering, a functional group like those with oxygen or multiple bonds are always more important than a substituent. So, we always number from the side where the functional group is closest to the end. In the case of alkanes, where the single bonds aren't numbered, we look at whichever substituent is closest to the end. There are no substituents that are more important than others. If the functional group is right in the middle and can't give us an indication of which side to number from, then we will look at the substituents to determine the numbering. When arranging the substituents at the front of the root word, we list them in alphabetical order and not in numerical order. Let's look at the following example. Step 1. Find the longest chain that contains the functional group and gives us the simplest side chains. We see that our main chain contains 6 carbons, therefore our root word will start with hex. Step 2. Identify the functional group. Our chain contains a double bond, therefore our root word will end with ene. Step 3. Identify substituents. We have an ethyl group, a methyl group, a chloro group, and a bromo group. Step 4. Assign positions. The functional group takes priority over here, and since it's closer to the right of the chain, we will number our chain from the right. This places our double bond on carbon 2, ethyl group on carbon 3, methyl group on carbon 4, chloro group on carbon 5, and bromo group on carbon 6. Step 5. Put it all together. We start by listing our substituents in alphabetical order. 6 bromo, 5 chloro, 3 ethyl, 4 methyl, hex, 2 ene.